All right, guys, lesson 4, and this is going to be the official end of electrochemistry. So we're focusing on electrolytic cell. We looked at galvanic, and then we began electrolytic. We didn't do much questions on galvanic because I wanted to cover electrolytic and then combine the questions together. But what did we say about electrolytic cell? It is a non-spontaneous cell. Okay, if you remember, we spoke about it. Hello. Let's see. You cannot see my screen. Okay. Did I share? Oh, sorry guys, I didn't share my screen. Thank you. Let me know. You should be able to see it now. Okay. All right, thank you for that. Okay, so here is the story about electrolytic cell. Oh, please, 1 second. 1 second. 1 second. There is a parent that I need quickly. 1 second. Okay, all right. Am I audible again? Let me know. Can you still hear me? Okay, so we said electrolytic cell. This is just a quick overview of electrolytic cell. It is a cell that converts electrical energy to chemical energy. We defined electrolysis. It's non-spontaneous and it's endothermic. The electrical energy used is a DC, and that is to maintain polarity. Then we looked at the 3 steps of electrolysis. Oh, we said the 2 cells. All right, electrons move externally from anode to cathode always. The anions also goes to the anode, and cations go to the cathode always. And these are the 3 steps, the breaking down. So we break down our electrolyte. Okay, and we spoke about, we defined electrolyte. We spoke about certain things. The higher the concentration, the higher the conductivity. The stronger the acid, the higher the conductivity, because more ions are present. And then we spoke about polyprotic acid as well, because it donates more ions, then it becomes more conductive. So that would break down, and number 2 and 3, migration, and number 3 would be just redox. So it's important to just go through these 3 steps. The first one we looked at was electrolysis of copper chloride, and we used 2 things. We used copper and carbon. Okay. And we also dealt with electroplating, just the covering of a metal with another metal. All right, today I want to look at electrorefining, and after this we will just move with whatever question we see. Electrorefining. Okay, then from there we answer questions. Electrorefining. And this is also called the purification of metals. The purification of metals. So when metals are extracted, they are not extracted as pure metals. They are extracted as ores. And ores are usually not pure metals. So we're going to go through that. Now, please, I want you to remember what we did last week. And this one is as well. I'll show you that all of these things are still the same. It's as if you are still electroplating. Okay? It's as if you are electroplating. Okay? So, electrorefining is the purification of what? Metals. Metals are usually extracted as ores. Metals are extracted as ores. That is, contain the main metal that we want to purify, and what? Impurities. It contains impurities. When we say impurities, it doesn't mean things that are dirty. For example, if I want to extract copper, so I'll have maybe something that has 98% copper, and then I have zinc and tin and aluminium mixed together. Those are impurities. So don't think of something that is dirty. Okay, it's not just what we want. Okay, that's a very important point because I'm going to come back to it. Okay, so we want to extract, and basically, quick note that will help you. Think of electroplating a tiny piece or a tiny rod of pure metal. I'll show you what I mean. Think of electroplating a tiny piece or a tiny rod of pure metal with another metal to be purified. Another metal to be purified. You would see it just now. Why do we purify metals? Why do we purify metals? Basically, to increase conductivity of the metal. Hi. To increase conductivity of the metal. So for example, copper, to increase the electrical conductivity, pure copper will transmit current better. Now, let's go back to that quick note. I want to look at it. That's purification of copper. Now, guys, I want us to purify copper. And what do we need to do if I want to purify copper? Remember what I said. It's as if you want to electroplate a tiny plate of copper. So I'm going to have a tiny plate of copper there. And I'll have my impure metal. That one is the big one. Impure metal. That is, this metal will contain copper, it will contain zinc, it will contain aluminium, whatever. Those are impurities now because they're not copper. And I want you to think about it. This is what? Thin, pure what? Copper. So we want to take the copper from here. That's why I said think of electroplating. So you are electroplating a thin pure copper with more copper. So it's electroplating in a bit.
Will you also do this to other substances? Like
every other substance. This is just purification.
That's how you separate it.
That's how you separate it. All right? And then, therefore, this becomes my anode and this is my cathode. The pure become, because I want to see copper there. So positive and negative. This becomes my cathode. And this becomes my anode. Now, we can go through the same process that we've been going through. What salt can we use? We can use what? Since we are dealing with copper, we use a copper salt. Copper nitrate, copper chloride, copper salt. With copper, any salt works. Yeah. All right. So let's use copper. Let's use copper chloride. Copper chloride. And it's all about our 3 steps. Once we remember those 3 steps, what's the first one? The breaking down. Step 2, the migration. Step 3 is redox. You're done. So we're going to look at those 3 steps. Are you done with the left-hand side?
Okay, left hand.
You sure? Okay, now guys, let's go through it. Once we are done with this, I'm going to look at one more electrolysis. Okay, what's our first step? Do you remember the first step? Ooh la la. Do we remember our first step? The breaking down of the what? Electrolyte. What's our electrolyte? Copper chloride. Okay, so copper chloride breaks down into what? Cu2 plus and what? Cl minus. Remember, it is now what? However, I want you to see something. This whole electrode is a metal. The copper in it starts dissolving. You know what's going to happen? Other metals are going to dissolve too.
Yeah, not just the copper.
Not just the copper. Every other, because now the whole rod is dissolving.
Yeah. Okay. Yeah.
So the anode is decreasing. Everything is going down. But our focus is on copper. That's why we're using copper chloride. So
only the copper will stick to the anode. I mean yeah.
Yep. So we have Cu2 plus and Cl minus, right? Okay. This one would come here. And the Cl minus, remember, like charges, what? Repel, and unlike will attract. So, but I want us to see what's going to happen. Since our focus is on copper, at the anode, the copper solid would then be oxidized to what? Copper 2 plus. Basically, it's what we did on electroplating. Okay? At the cathode, what happens? The copper 2 plus gains electrons and becomes what? Copper solid. Basically, we've transferred the copper now. Are we good? So we are electroplating. However, other ions are present. Let's say other cations are present. Usually when they give you this question, I didn't look at the question, I shouldn't. When they give you this question, okay, I just wrote zinc and aluminum, but when they give it to you, what's going to happen is this. Copper would be the stronger oxidizing agent than the others. So for example, if you remember, zinc is on top of copper, so copper is reduced. Aluminium is on top of copper. Copper is reduced. So other cations are present, but copper 2 plus is a what? Stronger reducing what? Agent than the others. That's how they're going to pose the question to you. Hence, will be reduced. The other cations form an anode dust. We call it an anode dust, which, when solidified, is called an alloy. And an alloy is a mixture of metals, and that is very expensive. Alloy. The rim of your cars, have you ever heard of alloy rims? Because now it contains the property of zinc, contains the property of gold, contains the property of whatever is present in there. So it's a mixed masala thing, that mixed masala tea. You know what I mean? So it's not only silver, it's a mixture. You've got a bit of diamond, you've got a bit of, so you'd find something silver but has the strength of diamond, has the shining capacity of gold, has the brittleness of another metal. So it's taking all of this. So that's called an alloy. You have a teacher who can teach maths, physics, isiZulu, Afrikaans, life orientation, all in one piece with accounting and geography. You understand? You're like your primary school teacher. Yeah, you're laughing. Your grade one teacher is an alloy. Hello, everybody. It's now arithmetic. Boom, done. Bring out your English books. Boom, done. Bring out your coloring books. Boom, done. It's now time for LO. Boom, done. One teacher the whole day. It's now Afrikaans. It's now Zulu. That is now EMS. That is an alloy. Because it contains different metals with different what? Properties. Does that make sense? So that is called an anode dust because it forms right at the bottom of the anode.
It doesn't become aqueous.
Sorry?
It doesn't go into our aqueous solution.
Now, it goes into the solution, but it can be solidified. And why do they come together at that point? Because when we do that, we say copper will be stronger than, copper 2 plus is a stronger oxidizing agent. So only copper 2 plus will be reduced. The rest is left there. Guys, we are done with electrorefining. I told you it's basically electroplating. So you are electroplating a thin what? If it's silver, you are electroplating a silver. But if it's silver, you cannot use silver chloride. Because silver chloride is a precipitate. We are done there. Did it make sense, guys? One page. Let me know if it makes sense. And it's just my 3 steps. Breaking down, movement, and redox. You just need to study what's going on in the reaction. That's all. Are we okay? Let me know. And finally, we'll look at one more, the electrolysis of brine. Brine, B-R-I-N-E, sodium chloride, yes. Concentrated sodium chloride. Now, this particular cell, usually we used to have it as a membrane cell. Well, life science is cell membrane. Now, this one is a membrane cell. But the membrane cell has been removed from the syllabus, but the electrolysis of sodium chloride is not removed. Last year there was a problem. They brought in the membrane cell. They had to remove it. They had to remove it because we are no longer teaching that. Okay, but quickly before we answer questions, remember when we start answering questions now, it's going to be a mixture of galvanic and electrolytic, and also we do some stoichiometry there, but I want to quickly look at electrolysis of sodium chloride. Okay, so there we go. All right, electrolysis of sodium chloride. I would quickly say this. My electrolyte is concentrated sodium what? Chloride solution. And my electrodes will be carbon. And please don't get it confused, okay? With this one, when we say solution, we are going to consider water. So, but you are going to see some other questions that say copper chloride solution. Please don't think of water there, okay? It's only this one that we bring in the water, and it's for a particular reason. So I want you to please stay focused on this one. So here we have what? NaCl plus what? H2O. Positive and negative there. So this becomes my anode and that becomes my cathode. Guys, yes, it was tested in trial 2024, but they can test it, but they cannot test that particular cell. But this can be tested in terms of electrolysis. Please, let's watch what's going to happen. What's the first thing? The breaking down of my electrolyte, which is ionic, sodium chloride. So NaCl would break down to what? Na plus, Cl what? Minus. Both what? Aqueous. Remember, my electrodes are what? Carbon. What's the other word for carbon? Graphite. Basically, I can actually do this with your pencil lead. What's in your pencil? It's graphite. Okay. So, if I then have, I want you to follow the process. It's not something you should cram. You must just enjoy the process. What happens to the Na plus? Remember, the cathode is the negative. So it comes here, right? And the Cl minus would go here. Are you with me? Okay. So what do we have on the anode side? Let's look at it. We are going to have our solid what? Carbon. Is that fine? We are going to have our chloride what? Ions. But there's water present in the mixture. Let's go to the right hand side. What are we going to have? We are going to have our carbon. And then we have what? Na plus. And we're going to have what? Water present. So we are done already with migration. What happens next? Oxidation and reduction. Okay, let's see what's going to happen at the anode. What are we expecting to happen at the anode? Oxidation. Anox. Okay. Which one will be oxidized? We need a table. We have carbon, chloride, and water. Okay, let's go check a table. There's no need to look for carbon. You won't find it there. It's inert. Oh, why is my table so far? What was I doing so much? Huh? Why is, oh wait, there's a table, there's one okay, yeah, this is the one I'm looking for. Let's bring it close. Okay, if you have a table, please start, there's no need to find C, you won't find it there. So don't disturb yourself. What are we looking for? Cl. Is that fine? Okay, let's go check everybody. We're going to check together. I just want to bring it close so that I don't start moving too much. Wow. This, you see, this note can actually form a textbook. I promise you. Okay. Where's my highlighter? You won't find it here. You won't find it on top. It's not here. Most of these are metals. You're going to find it down here. Okay, watch this. There's water and Cl. So that's my Cl there. Okay, I want to show you something. That's my Cl. Where's sodium? I need sodium. Where's sodium again? Oh, here is sodium, right? And then we have what? Water. Is that right? Okay. Now, on the anode side, we are expecting what? Oxidation. Is that okay? Please watch something. On the anode side, we are expecting what? Oxidation. I want you to compare. Look at this. What do I have? I have water, right? And I have chlorine. Are you with me there? Mm-hmm. I have water and I have what? Chlorine. If I write my Z, I want you to see something. That's my Z. What should happen? Okay, please, I like what you just said. Again, I'm going to slow down now. If I write my Z, I'm expecting that water should be what? Oxidized. And if it's oxidized, what should I be having? This would become that. But I don't have this. I don't have hydrogen gas. I don't have hydroxide ions. I have water. So oxidation of water cannot occur. I want to repeat that again. According to our table, this one is on top and this is at the bottom. We are expecting oxidation, right? Ta, and that. Oxidation says I should have this to give me water. But what I have is water. So it means water cannot be lovely. I have to oxidize what? Cl. Wait, if I oxidize, where do we start writing from? The left. Always think about it. From the it means this becomes a reactant. Do we have Cl minus? Yes. So it means that at the anode, please, I want you to follow very well. But a lot of things are happening here. At the anode, chloride ions are what? Oxidized. What would that form? Check. Cl would give us what? Cl2 gas. We're going to have bubbles. Plus what? 2 electrons. How do we know gases are formed? Gases are formed by what? Bubbles. Okay, now, at the cathode, what's going to happen? Reduction. Let's go back to our table. We are now comparing water. Carbon is out. Where's this table run into? Carbon is completely out, right? We have, what do we have? Sodium ions and water. Check it. Sodium is on top. Water is at the bottom. If I write my Z, what are you expecting? Sodium should be what? Oxidized to sodium ions. Do you have sodium? No. We have sodium ions. And water should be reduced. Do we have water? Yes. So I want you to see that the table tells you what's going on. We don't have sodium ions. We have water. So water will be what? Reduced. Why is water reduced? We are at the cathode. Okay. So look at the equation. Water is now what? Reduced. What will the equation be? Water is reduced. Then I'll take your questions now if you have any. Water is, so remember we copycat. So what are we going to have? 2H2O plus 2E to give us what? Hydrogen gas plus hydroxide what? Ions. Why is water reduced? Water is a stronger oxidizing what? Agent. Remember, it's reduced, right? Than what? Please don't write than sodium, because we don't have sodium in this. So always check your table. Do we have sodium here? No. Then sodium what? Ions. Therefore, water is, this statement alone is 3 marks. Because I'm going to ask you, why is sodium ions not reduced? Sodium ions is not reduced because water is a stronger oxidizing agent. 1 mark. Than sodium ions. 2nd mark. Therefore, water is reduced. The 3rd mark.
But isn't that 3rd mark just like a repetition?
Do you care? Just get the mark. Because once you say it's a stronger oxidizing, we know it's going to be reduced. But we give a mark for your conclusion. So please take note of that. Water is a stronger, but we're not done with this cell. This cell is important. There's something important about this cell. I want to show you how these examiners play a lot. Okay, what possibly could be there again, right? Lovely. I love your questions. What are we forming? What are our products? Okay, can we write a balanced equation of this? Let's write a balanced equation. Are we done with this page, everybody? The balanced equation, do you notice the equation is balanced already?
Yes.
Okay. Are we okay, everybody? Can we move on? Okay, Fatima is waiting. All right, Fatima. Fatima, I should see you next week. I think so. She's laughing. Okay, let me know when we're done. Yes, I think it's just Fatima. Let me know. Michelle, how are you?
Is it me or Pastor?
Oh, okay. It's your Michelle, because I don't think the other Michelle is in class. Okay, let me say Nomti. Okay. All right. Klamani, how are you? Okay. Awande, Ibrahim, Fatima. Huh?
What's the purpose of the cell? Because it only creates gas.
Okay, I love your question. What is the purpose of this cell? What makes this cell very nice is the product. Okay, let's write the whole equation. You would see the beauty of the cell. The beauty of this cell is in the things that are formed. And I want to show you the trick there. Okay. Give me the balanced equation now. What will it be? Balanced equation with what? 2Cl minus plus 2H2O to give us what? Cl2, which is a gas, plus hydrogen gas, plus hydroxide what? Ions. Okay. Why is this cell important? The answer is here. First, Cl2 gas used in water purification. So if you are cleaning your pool, water purification is used in making bleach. If you want to know how chlorine smells, buy bleach. Okay, I don't know. I'm not sure. Don't let me lie to you. I'm not sure. So it's dissolved in water, and then you can have your HOCl. You bubble it into water. Yeah, and some other things, but you just bubble the gas into water, and a reaction happens. Okay, leave me alone. That's not what I'm doing. Okay, look at the second one. Hydrogen what? Gas. Used as rocket fuels. Hydrogen bombs. Okay, I don't want to write bombs here because I'm going to post this on YouTube. Okay, but because of the energy it produces. All right. Hydrogen gas is used as rocket. So rocket fuels are very, very important. There's more properties that we can use, but here is the beauty. Number 3. Are you aware that we have sodium ions still in this cell?
Yes. Yeah.
That did not do anything.
Yeah.
Sodium ions now you are there, react with the hydroxide ion that is formed to form sodium what? Hydroxide, which is caustic soda. Caustic soda used in making soaps, paper, paint. Oh, by the way, hydrogen gas is also used in margarine. Yes, this is your hydrogenation. Organic chemistry. Yes. Hydrogenation. Organic chemistry. So when we make margarine, it's addition of what? Hydrogen. So where is it produced from? Produced from this cell.
Why margarine? So if we synthesize margarine, we could possibly make rocket fuel out of it.
Yeah, but maybe low quantity though.
Yeah.
So look at how many things. Is there a day that you don't use any of these things? Please check. You use water every day. With water, you use the soap. Going to school, you have your margarine and your bread. Do you want to tell me how important this cell is now? It's an everyday use. Now, tricky questions that examiners usually ask on this would be, and that will be my final point, then we go to questions. We must go and check. Huh?
Yeah. You can.
Yeah, you can.
But you die. Not you die, you die.
Okay. Please, just an additional stuff. What is the test? What is the test for hydrogen? I'll be so happy if the examiner brings this. Test for hydrogen. So the examiner is going to say, how do you know that it's hydrogen that is formed? Natural science. No. We want a physical how do you know? Okay, how do you know that an oxygen is formed? No. Okay, bubbles is any gas. What is the yes?
I think the deficit for oxygen is a sea bubble before hydrogen near like a small box.
Good. There is a squeaky pop sound.
I can't be the answer.
You can't remember?
Then it can't be the answer.
No. So, test for hydrogen. If you place a lighted splint near the hydrogen gas, I'm glad you remember. A pop sound is heard. If you want to know that, one of the tests for hydrogen is if I put a lighted splint, it rekindles. So it's like, see, you're brine. Right? When you blow air, that light comes up again. That's a test for oxygen. It rekindles a blowing. But for hydrogen, you hear a pop sound. So that's how to know when hydrogen is formed. How do I know? Okay, look at the next one. How do I know sodium chloride is formed? And where is it formed? Sodium hydroxide. Huh?
On a large scale.
What? On a large scale? Not really. You can do it in the lab. You can do it here quickly. But, oh yeah, definitely industrial dimension. Okay. No, they know it's formed, bruh. They already know hydrogen is formed. They know they want to bomb the whole factory. Come on. Okay, around where are we forming the thing in? The Na plus would go to the negative, and the negative is the cathode, right? Around the cathode, sodium hydroxide is formed. And we can use an acid base indicator to check. Now you are there. Now we are talking about acid and base. And what are we going to be expecting? Color changes. Good. Litmus paper would be the easiest one.
Yeah, it's good. Just use it.
Yes, we did all of those in grade cabbage, onions, and whatnot and whatnot. Okay.
1900s.
So a red litmus turns what? Blue. A red litmus turns what? Blue with a base. When WhatsApp started, we used to write something called, if you're chatting with someone and I need to do something, what would you tell me? Like, we're chatting on WhatsApp now and I need to quickly do, how do you type it? Okay. Be right back. A base will turn a red litmus paper into blue. A base will turn a red litmus paper. So a lot of people do acid and base, but they don't know. Okay, guys, I'm done. I'm done with the whole concept for the year. Yay! Yeah, you are free to blow the. You are free to blow the. Is it vuvuzela now? Now, if I were to use that membrane cell, you know what's going to happen? It's this. In the membrane cell. Oh no, it's not that. It's fine. It's fine. I'm going to another cell completely. It's fine. Don't let. Yeah, but guys, this is it. From here, can we just answer questions for the rest of the whole session now? So we're answering both galvanic and electrolytic, just to make sure we cover everything they may ask you. I don't know if there's any question. We can go on. We can tackle whatever comes our way. Here's the first question. Oh no, not this one. There we go. Here's the first question. 12 marks. Do you want to try this for me? Guys, we don't need 12 minutes. We only need 7. Please get your table ready. So we will be correcting each other based on the language used as you answer. Okay. 7 minutes 30. It's too long, but it's okay. I'll cut it down the next time. Okay, guys, I hope we're done. Let's answer quickly. The simplified diagram below represents an electrochemical cell used for the purification of copper. And I'm glad we just did purification, right? First thing I need to see is what? An electrolytic cell. You know what I will do? I'll put a plus there and I'll put a minus there. And this is now my anode. What's the keyword? Ape. And this becomes my cathode. Basically, do you know what it means? This becomes my pure what? Copper. And this becomes my impure copper. By doing that, I have actually answered everything. Just by writing that little thing. State the energy conversion that takes place in the cell. What did you say? Electrical what? Energy. High. To what? Chemical energy. And we have our 2 marks in the bag. Please give yourself 2 marks. Define the term electrolyte. Ionic solution that conducts electricity through the movement of ions. Through the movement of ions. We're done. Number 3. Which electrode contains impure? That has been answered. Electrode A or B? Electrode A. Number 4. Write down the half reaction that takes place at B. At B, it's the cathode. We are forming a solid. So what do I have? Cu2 plus 2 electrons to give us what? Cu solid. Number 5. Which electrode A or B? Is electrode A the anode or the cathode? It is the anode. Why? It is connected to the positive what? Terminal. The 2 electrodes are replaced with carbon rods. We're going back to the first one that we looked at. Write down what will now be observed at A. Quickly, you know that at A now what do you have? You have Cu2 plus and you have what? Cl minus. The Cl minus would move towards A. And what happens? Oxidation, which means a gas will be formed. They said write down what will now be observed. Bubbles, which is the production of what? A gas. Bubbles are seen. And write down an equation to explain the observation made. You are producing what? Chlorine gas. What do you have? 2Cl minus to give us what? Cl2 gas plus 2E. And you are done with 12 marks. Just know your content. Don't make the anode the cathode. Don't make the cathode the anode. Then you're fine. 12 marks in the bag. If you don't know what... Yes?
By the iron.
Sorry?
The 2E is made by the iron.
No. This is oxidation. Go to your table and check. We're working backwards on the table.
Okay.
Are you sure? Are you okay with what I wrote? Okay. So use your table, and after a while, you just begin to know these things. We didn't even open the table to write all of this. Okay, everybody, here's the next one. Oh, we answered this one last week. We answered this one, but let's go through it again. What is this? The purification, no, electroplating, right? Whatever we want to electroplate, we said should be at the cathode. Identify which electrode is the anode. That. Copper. Which terminal must be connected? Terminal object. Cathode is negative. State whether copper ions are oxidized or reduced. We answered reduced. Half reaction there. AC or DC? DC. Reason? To maintain polarity of electrode. 7 marks. We're done there. Okay, that one we answered last week. All right, you answer this one. This one, there's a let me see what's going on. Why do I have 9.5? Oh, then it continues here, 13 marks, but we do it page by page. 2, 4, 6. Please answer this. Try to write all the definitions. Okay? Don't say, I'll write it during exam. No, write what you know now. And then we keep correcting it until it's perfected. Yeah. Three minutes for this first page. You need 2 minutes here. Once you remember your definition, the rest is history. But read on top first, please. Are we done? Okay, we answer this. In an electrolytic cell below, 2 carbon rods P and Q are used. And this is basically the question we came from earlier on, right? Define the term electrolysis. Now, that's a process, right? Process of what? Of converting electrical energy, because it's electro, so you are starting from electricity to what? Chemical energy. What observation? What observation can be made at P? Let's quickly look at it. Let's quickly analyze. That's negative, and that's what's positive. So what am I expecting here? Negative, I'm expecting Cu2 plus, and I'm expecting what? Cl minus. Automatically, what observation can be made at electrode P? That's the P now is the cathode, remember? And what happens at the cathode? What do you observe there? There are 2 observations that I would see. the mass of electrode gets bigger. Increases. A brown dust forms, remember we spoke about this, forms on the cathode. Write down the half reaction that takes place at Q. What are we expecting at Q? The chloride ions are oxidized. So 2Cl minus to give us what? Cl2, which is a gas, plus what? 2e electrons. We're done. Name of the form or formula of the reducing agent. We're talking about what is oxidized. And where does that happen? At the anode. Or if the name would be what? Not chlorine. Chloride ions. Number 5. What is the function of CuCl2 as electrolyte? They are simply asking you to define electrolyte. Allows what? Electricity to pass through. Because that's the function of an electrolyte. Allows what? Electricity or current to pass through. Allows current to move through the movement of what? Ions. Okay. So they were just asking for the definition of electrolytes there. Okay, we have 3 more questions I think on that. So let's go back quickly. I'm sure you know the cell. Oh, beautiful. I love this one. Do you want to sketch this? You don't need to sketch. Okay, just look at the P and the Q. Sketch that P and Q quickly. P is the cathode and Q is the anode. Because all of that questions then rely on that. You have your electrolyte as what? CuCl2. You'd remember that, right? Okay. We answer how many? 6 marks. Which one is my anode again?
Q.
You sure?
Yeah.
Okay, so Q is there. Let's just have it here. And P is the what? Cathode. Okay, quickly answer these questions. Let me know. The guys here are done. I don't know whether they did what's correct, but they said they are done. Are we also done?
Yeah.
Is it the same feeling for those of us at home? Amani, are you done? Okay, Kian says no, guys. Yes, you guys did something wrong. He's not done. Amani is also not done. Okay, 1 minute and 30 seconds left.
So become about
Oxidation, not reduction. Okay, guys, let's check. You see. The cell is now used to refine copper. Remember, the pure one goes to the cathode. Which electrode, P or Q, will have to be replaced with copper? P. The answer is what? P. Give a reason for your answer. Reduction occurs, or let's say reduction, guys, we did all of this, it's in the note, of 2 plus occurs at the what? Cathode. Remember, to form this, you don't need this, but just to explain further, to form what? Copper what? Solid. Explain why the concentration, that answer remains the same like we did last week. The rate of reduction of copper 2 plus is the same as the rate, do you remember this, of oxidation of copper. Please know when to use the ions, know when to use the solid. All right. Solids are oxidized, ions are reduced. Silver and platinum are formed at the bottom. That's my anode dust, okay, of the impure copper. Now, remember, the impure copper will be at the what? At the anode, where oxidation will what? Take place. Refer to the relative strength of reducing agents to explain why these two metals do not form. I don't need a table. Check. Reducing agents, we're talking about something that is what? Oxidized. And we know what is oxidized. What is oxidized? Copper. So copper is a stronger what? Reducing agent than what? Silver, not ions now. Silver and what? Platinum. I need to go back and change something. Hence, copper is what? Oxidized. And when copper is oxidized, we can put into what? Ions. Copper is a stronger. Now, do you notice I'm not saying copper ions? Because at the anode we have all solids. Copper is a stronger reducing agent. Hence, copper is the one that is what? Oxidized into the solution to become Cu2 plus. Let's check something here. Let's go back quickly. I want to just make an amendment on something here. Where's my anode dust? Check here. My anode dust. All right. I said, however, all other catalysts are present, but copper 2 is what? A stronger reducing agent will be reduced. I want us to add that one here as well. Here we can say what? Copper is a stronger what? Reducing agent than other metals. So copper is oxidized, leaving the other things. I want to, guys, you know what? I want to clean this one. I want to let me alter this. I want us to change it because I wrote ions here. I want us to remove the ions. Yeah. Let me bring that statement here. Copper is stronger. Just alter that note for me. Stronger reducing what? Reducing agent than other impurities, other metals that will be found there. So copper is what? Oxidized. The other, okay, then we bring in this. The other metals, let's remove the word cations. The other metals form an anode dust, which when solidified, actually it's still a solid, which when solidified is called what? An alloy. Okay, so it's a dust, but which when made into a real solid forms what? An alloy. Please just quickly fix that note for me there. We don't want them to form ions. But if you check, everything is in place. Everything is in place. That's my anode dust, or which we know as what? Alloy. Huh? AG.
Oh, that's why actually it was AU.
AU is gold.
Yeah. Okay,
And AU is not on our table. Okay. I want us to go and do some stoichiometry now. Let's look for ones that have stoichiometry. 5 marks, 6 marks. And then we go, okay, so we look for one stoichiometry, and then we look for some 2 galvanic. Let's see. I need some stoichio. So if I don't see stoichio, I'm going to pass, right? Until I find a stoichio one. What's happening here? No, electrorefining. Guys, I don't think there's any question here. I don't think there's a question here. Is there anything? The simplified diagram represents that. We've done this. The impure copper becomes what? The anode. Don't forget, the thin one becomes the cathode. All these are repetition. Write down the name or formula of the electrolyte. You have even been seeing it in questions. Just copy what you have been seeing in questions. Copper what? Chloride. Okay, guys, I'm looking for stoichio because I think I'm boring you now. Can I quickly look for a stoichio? Then we come back to galvanic cell. Okay, we're going to end with all galvanic cell, especially that one. Okay, I need to do 2 of this. I see something here that says pH. How will the pH of the solution? Ooh, nice. Don't tell me I don't have any stoichio. Oh, here we go. Okay, so this is question 8.2. Let me see something. And okay, let's answer this one. I see some stoichio here. Then after this, guys, we just answer some galvanic. Otherwise, I'll look for another stoichio if possible. Then we answer 2 galvanic cells. You can see that it's 5 minutes each question. Okay, let me take you through this. An electrochemical cell. Okay, what is this? An electrochemical cell is set up using the redox reaction below. Now, immediately I see this cell notation. It's galvanic. Only galvanic have what? That. So this is what? How do we write our cell notation? Do you remember? It's as simple as A, B, and C. Please try. Let's see. I want you to try to write that down. You do remember the cell notation, right? Let's try quickly. Are we done? Cell what? Notation. Okay. So we have Mg and AgNO3. Mg solid, and don't let the thing disturb you. It's Ag silver nitrate, right? To give us what? Magnesium nitrate, but that's a 2 because it's Mg2 plus what? Ag. So let's balance this. I need a 2 there, and I'll need a 2 there. Look, instantly, for you to find out what is oxidized, write oxidation number. What's the oxidation number of Mg? 0. What's the oxidation number of silver here? It's silver ions and nitrate ions. So oxidation number here is what? Positive 1. Now, what is the oxidation number here? It's an ion, so it's Mg what? 2 plus. And what's the oxidation number here? 0. That you must quickly know. Now, if you notice from 0 to positive 2, what is that? It's an increase, which is oxidation. From a positive 1 to 0, what is that? It's a decrease. Please, I need you to ask me questions here if you are lost. Reduction. So I know what is oxidized and what is reduced already. So what is my cell notation? At the anode, which one is the anode? Mg. So what will it be? Mg solid. It's oxidized to what? Mg2 plus. Can you see my oxidation there? Salt bridge. Shamil, I need you here. What do I have? Ag plus. And what? Ag solid. I have my 3 marks. This is what happens at the anode, and this is what happens at the cathode, and that's my salt what? Bridge. Remember, solid must start and solid must end. Please ask me questions here if there's anyone who is lost, especially on oxidation what? Numbers. Please ask me. I'd love to take your questions.
Mg and then Ag.
Sorry?
Do you write Mg and together on the...
Yes. Because you're telling me that is what happens at the anode. Mg is oxidized to Mg2. And you can actually see the oxidation number increase there. That's a 0 and that's a positive 2. While this one is a positive 1 and a 0. But the key is you must start with a solid and end with a solid. Are we okay, please? Are we okay? Thumbs up, everybody. So you can see we are going from an equation straight to the cell notation.
So if it's in the same phase, then what do you use to separate?
A comma or a semicolon. We'll do something like that shortly now. We'll do something like that. Okay, let's run now quickly, everybody. Write down the conditions needed for this cell to operate. I gave you 3. But in this case, only 2 are applicable. Which 2 are applicable? Temperature of what? 25 degrees Celsius. And what? Concentration. Remember, please write the values of 1 mole per cubic what? Decimeter. We are done there. Number 3. Calculate the initial EMF of the cell. 4 marks. What's my formula? Do you remember? E cell equals to what? E cathode. Do you have a table there to get me? The cathode is what? Silver. 0, comma? 2,26. And what would that give us? 3,16 volts. I always like to put the positive in front. Spontaneous. You get 4 marks there. In fact, if you get a negative, know that you've done something wrong and go and fix it. That's the whole idea. Once I get a negative, I know I've switched to my anode for cathode. Don't just switch it there. Go back up everywhere you have said anode. Quickly turn it back to cathode. Let's just be clever about it. Lovely. Number 4. It says the cell is now connected to a light bulb which is marked 3 volts and 6 watts. In theory, the light bulb should glow, but it does not. Without any calculation, give an explanation. Hold on. They said it's marked with what? 3 volts and 6 watts. 8.2.4. 6 volts and what? 3 watts. Is it 3 watts?
3 volts, 6 watts. Yeah.
3 volts and 3 volts and 6 watts. In theory, the light bulb should glow. Why should it glow? It should glow because the current I'm producing, can you see the voltage? 3,16 volts. In theory, it should glow, but in practice, it doesn't. Without any calculation, give an explanation for this. No, standard conditions are fine. Once we do that calculation, standard conditions are fine. Huh? Internal resistance. It's a battery. So there is possibly what? And what will your internal resistance do? It will decrease the voltage available. The external voltage. So one of the reasons could be due to what? Internal resistance. Remember, it is a battery. Okay, next question. Are we okay? That's a beautiful one. All right, the volume of the electrolyte in each half cell is 0.4 dm cube. Calculate the loss of mass that can occur. Let's be smart about this. At the anode. Okay, do you notice the anode will always lose what? The anode will always lose mass. Okay, when I see this, you know what I will do? I'll write the equation that occurs at the anode. What equation occurs at the anode? Let's quickly see 8.2.5. We start by the equation. What's the equation? Mg to give us what? Mg2 plus what? 2e. Are we good? The examiner says we should calculate what? The mass. If the volume is what? 0,4. I wanted you to learn to be creative. We are looking for the mass. Are you with me? Mass. What is volume again? 0,4. To get the mass, what do I know? Mass over what? Molar mass. Okay, let's see something. We need to play around here. Molar mass we can get. The problem is what? Number of moles. Huh? No, because we don't have molar volume. When you say V over Vm, we need molar volume. Okay. But check something. They gave me volume. This is an ion. Right? Are you aware that we have the concentration of this? It's standard. 1 mole per dm cube. And I have my volume. Do you notice I can calculate the number of moles here? So, number of moles or concentration is what? So, do you see what I did? I wrote everything I have down to then see. N over what? V. So, what is my C? 1. N over what? 0,4. So, the number of moles is what? 0,4 moles. Now, do you notice that Mg to Mg2 plus is the same number of moles? 1:1. Make sense? Lovely. So if this is 0,4, this would also be what? Now, number of moles is mass over molar mass. 0,4. Magnesium is what? Do you have a periodic table there? 24, I think. Please check a periodic table there for me. Guys, are you okay with my analysis of the stoichiometry? Write out everything you know. You know what I want you to forget? You're going to be thinking, but I don't have concentration. 24. You're going to say, but I don't have concentration. Standard condition. 24 times 0,4? 9.6 grams. Beautiful stoichiometry. Okay, guys, I was checking for those of us at home. Are you okay with the stoichiometry I did? Did it make sense? So, outlay what you have. You'd see where you're going. Outlay what you have, and you see where you're going. Don't let the 6 marks scare you. Okay, beautiful. Let's answer one more galvanic, and then look for one stoichiometry on electrolytic. And then we'll be done, guys. The rest is just for you to apply. The galvanic I want us to answer, let's see. This one. Let's answer this one together. I'm going to pause. After reading, you're going to write your answer, then I write my own for each question. Okay. A galvanic cell is set up under standard condition. 1/2 cell consists of silver plate, Ag, in an aqueous solution of silver nitrate, while the other consists of what? An inert platinum plate. Inert. Okay? In an aqueous solution of Fe2 plus. And if you go back to your note, I gave you when and why we use platinum. When do we use platinum? When I have a gas, when I have a mixture of ions, and when I have what? A non-conducting element. If you can go back to your note, you'll find it. And why do we use platinum? It's solid, it's a conductor, and it's inert. Why and when? Lovely. So you can see there, what do I have here? A mixture of ions. That's why I have what? Platinum. All right, write down the energy conversion that takes place. What type of cell is this? It's a galvanic cell. We are producing, it's a battery. So we are producing what? Electricity. So what's your answer? Chemical energy. I'll tell you one mistake that learners write. They write mechanical. I don't know. They are doing physics and chemistry. Mechanical energy too. I don't think it's their fault. It's just stress. Number 2. Now, guys, quickly identify for me the anode and the cathode. Use your tables. Use your tables. That's the only thing you can do. But on the table, please listen. On the table, no, there's AG. There's no AU. But on the table, I want you to look at something. Let me go show you a table quickly, everybody. Please, I want you to take note of this. Here is the catch on this question. Here is the catch. We're using FE, right? Okay. Quickly take a look. 30 seconds. Ta-na-na-na-na-na-na-na. Ta-na-na-na. Do you see that? Ta-na-na-na. Ta-na-na-na-na-na-na-na. Ta-na-na. Ta-na-na-na. Ta-na-na. Ta-na-na-na. I have 3. Which one do I use? I think we discussed this. The cell has what? Fe 3 plus and Fe 2 plus, if you remember. Check. That's the one I'm going to use. All right, quickly. So please tell me which one is oxidized and which one is the anode and cathode. Quickly, everybody. Make sure we get that right.
What do you do if it's in between them? Like say for example, like if AG was between 2 plus and 3 plus.
No, there's an equation that has the 2 plus and the 3 plus together.
Yeah. Oh.
Yes, there's an equation that contains both the 2 plus, one equation, one of the FEs. Yeah. It has Fe3 plus on one side, it has Fe2 plus on the other side. Have you found it? Please, I need you to get this one, because guys, once this one is wrong, the whole story that you're going to write will be wrong. Okay? Come, let's look at it together and we move. Where's AG? Have I passed it?
No, AG was the bottom.
Where?
Page is in the next slide.
Next slide. Okay. Oh, here.
Yeah.
Now, which ion? This. So you see Fe3 plus and what? And we find it before the anode. We find it before Ag. The one on top becomes my anode. It is anode and cathode. So do you notice that we are then done with this beautiful question? And I'll tell you why I chose this question. First is to find out which of the ions to use, and number 2, how to write your half reaction. What is this? That's going to be my anode, and that's going to be my cathode. Make sense? Oxidation. You start from the right hand side, go into there, and always, even look, I can do it without a table. What is oxidation? An increase in oxidation number. What's the oxidation number of Fe3 plus? 3 plus. What's the oxidation number of Fe2 plus? 2. So I should remove him from what? 2 plus? I don't know if it makes sense. That if you understand, you can do almost everything without the table. 2 plus. With oxidation, the electron is always on the right hand side. I'm done. Cell notation. Cell notation is as simple as what? A, B, C. Which one is my anode now? Fe2 plus, which is what? Aqueous. Fe3 plus. Do you notice that, guys? I cannot do this. Same phase. That thing, I told you what it means. It means it's called a phase separator. We use it in separating what? Phases. But they are of the same phase. So what should I do? A semicolon there. By the way, this is wrong. My cell notation must start with a solid. So what's my solid? Platinum. phase change. Now, salt bridge. Then I have my cathode. What will it be? Ag plus, which is what? Aqueous. And end with a solid. Ag what? Please let me know if that makes sense. I want to do one stoichiometry of electrolytic cell. I'm going to quickly look for it. But are we on the same page here? A quick response, I would appreciate that. No questions, we're good. Two standard conditions. I cannot use a gas. So there's no pressure. I can't use a pressure because there's no gas. So what are we talking about? Temperature of 25 degrees Celsius. Please, a quick warning again. You write the values. And what is my concentration? 1 mole per. Okay, I'm done. Calculate the EMF, guys. I'm done with that. Moving quickly. Now, what would happen to the EMF calculated in question 8.3 if a solution of what? Sodium chloride were to be placed in the salt bridge? Come with me. Let's put sodium chloride here. Remember, we have Na plus and what? The plus are called what? Cations. And these ones are called what? The examiner wanted something. The examiner wanted to form silver chloride. But it's not forming. Do you notice the cations will come to the cathode? They wanted to switch this thing. That's what I see. Here, nothing, it remains the same. It will not. But if the Cl had come into the silver, the EMF value in that, but the E cell would decrease. I spoke about this when I give you a table. I spoke about it when I spoke about contamination. But unfortunately, they wanted to do that. Explain your answer. I think I remember this. I remember this question now. The memo had it the other way. Then the teacher actually sent me this to say, is this correct with the memo? I remember it's from Eastern Cape. I don't remember the year. So the examiner wanted the chloride to move into the silver to form Ag, because that's what the memo said. But it's wrong. They should have used a different element there. Maybe they should have used iron itself. Then that will have. But I hope you get the whole system. So here they wanted to form a precipitate, but it was an error. They didn't form the precipitate. So I don't know whether they cancelled the whole question of 8.4, blah, blah, blah. Okay, but anyway, according to this, it will remain what? It will remain the same. Okay? And why would that remain the same? No precipitate is formed. No precipitate is formed as the sodium ions move to what? The cathode, and the chloride ions move to. But you understand my concept, right? The examiner wanted the chloride ions to go into the silver to form what? Silver chloride. Can we just tweak it? Let's tweak it quickly. Let's tweak it. If the Cl ions move to the what? Cathode, AgCl is what? Formed. Now, that is the cathode. It means the concentration of Ag ions will what? Decrease. Remember, it should be 1 mole. If the cathode decreases, you know what's going to happen? Already we have formed the precipitate, right? Look at what happens. The system will favor, this is Lechetelia. The system will favor. Now, quickly put in your head. I want to show you, you don't need to cram this. You're going to be very smart As I'm talking to you, I don't know the answer, but I'm going to show you how I'm going to get the answer. I know how to get to the answer. I'll come back and say, but we said E cathode minus what? E anode. Because the concentration here decreases, this value will decrease. And if that decreases, E cell will what? Decrease. And for E cell to decrease, we favor the reverse what? Reaction, which is reduction. And I'm done. I'm going to put all of that there now. So, if the Cl ions move to the cathode, AgCl is formed. Silver concentration does what? Silver ion decreases. The system will favor the reverse to form more what? Ag what? Ions. E cell value will what? Decrease. What you need to remember is use the formula. If a cathode decreases, the E cell will what? Decrease. For the E cell to decrease, we must favor the reduction. If we favor the oxidation, it will increase. Guys, please go back to lesson number 2. It's all there. I spent time on contamination. All in there. Lesson number 2. Okay, so please, that was what we wanted to test there. Blah, 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 blah. Time is almost up. But I want to do, if I don't have it, guys, all of this is nonsense. This is class example. Please, here you must get your 13. Function of the cell, which is anode or cathode. Use the table. Copper half cell, silver half cell, net ionic equation, you balance, EMF, state the standard. This is what you teach grade 8 quickly and ask them. Galvanic cell, right? There's a gas there. So we need to bring in what? Platinum. Standard conditions, besides a temperature of 25. I need pressure now of 1 atmosphere. Initial reading, energy conversion, function of Q, direction in which the anions flow. The anions will always move to the anode and cations will move to the and anion, cathode and anode you can fix from the table. You have hydrogen and nickel. Done. How will the pH of the solution be affected after a while? Choose increase, decrease, or remain. This we can only answer once we know our anode. Can I answer that quickly? Please, which one is my anode? You sure? You sure that nickel is on top?
Yeah.
Confirm. Quickly, I want to just answer that.
Yes, sir.
The boys swallowed the table. Okay, nickel is what? My anode, and this is what? The cathode. Watch this. Can I then write the reaction at the cathode? Because the examiner is asking for the pH. Look at this. At the cathode, do you want to give me? We copy and paste the table. Give me the hydrogen there. It's hydrogen gas.
Hydrogen gas will form 2 hydrogen.
It's reduction, right?
Yeah.
It is
Yeah.
that to form what? 2H plus. Okay, please look at this. What are we doing here? Do you notice that we are forming more hydrogen what? Ions.
So the 2 must be by the 2H.
What do you mean?
By the H2. The line will not be.
No, H2 gas give to H. There's a 2 must be back to the H side.
Yeah, H2.
H2.
2H2.
Yeah. And then the 2 must come out by the H plus.
Are you sure?
Wait, what?
What you?
No, it's right, it's right.
No, guys, don't confuse my soul here.
2H plus.
No, it's H2 gas to give us 2. Which one are you looking at?
I'm looking at this one.
Yeah, but it's the. Oh, cathode. Wait, what table are you looking at there? Okay. Mohammed, leave me alone. Let me go back to the table. Okay, guys, it's the cathode, right? I just want to show you something that Learn to use the equation to answer the question. Okay, what is the hydrogen? Okay, it's 2H plus, okay, you are right, plus 2E to give us what? Hydrogen gas. 2H plus. This is just to quickly show you how to maneuver the equation. Please don't just write an equation blindly. Make sure you understand what the equation is, and that's what I wanted to see. Look at this. Okay, so we are wrong here, right? What's it again? 2H plus what? 2E to form what? H2 gas. Okay, guys, what are we forming? We're forming a gas, right? Do you notice that the aqueous is being reduced? So what happens here? Concentration will what? Decrease. What is pH? Negative log. Now, if the hydrogen ion concentration decreases, if you are not sure, look at what you can do. Create a number. You are not sure because you don't know how the log behaves. So, create a number to say, okay, I want to start with 0,2. Then I want to compare it to what? Let's decrease it, 0,1. Which pH is bigger? Try it. Do you notice that you'll be thinking that it's decreasing? I don't know if you get the whole idea. That, okay, so use the log value. So you will notice that as the concentration decreases, the pH value does what? Increases. What was the value for 0,2?
0,7.
And 0,1?
1.
Makes sense because if your hydrogen ions are decreasing, it's becoming more base.
I don't know if it makes. Do you understand? So the pH scale is very tricky. In your head, you are thinking, it's going to. All right. So pH value will what? As concentration decreases, pH value does what? Increases. And I'm done there. Explain your answer. That's my answer. Sorry? Yes. That's actually better because if your answer is wrong, then we don't listen to your explanation.
But even in MSc
No.
they listen to your explanation myself.
They said choose increase. No, you can't explain. Okay, here you can. No, but no. They said choose increase. You have to answer first. It will but you do your explanation and you just write what? Increase. Why? The concentration does what? Decreases. And then you can just, if the concentration decreases, it is actually becoming more basic. pH is now what? Increasing. Guys at home, I hope my little craziness makes sense to you there. Just be analytical when you answer your questions. Talk to me. Lovely. Be creative. Don't get stuck. The platinum electrode is replaced with a larger platinum. We did mention this. Where is the platinum? The platinum is on the cathode. What's going to happen? What's going to happen? No, it will have an effect on the EMF because we have more electrons now. So if we have more electrons that are present, and it's at the cathode, the EMF will increase. Once whatever happens at the cathode, if it increases, boom, EMF will what? Increase. Okay. All right, guys, I'm tired of talking. I was looking for something before I jumped into that question. But please, we just need to practice multiple choice. All of this is the same story. Same story. Same story. Huh? Which one? Woo! Okay. Do we have time? Let's try to do this. I see some dangerous questions here. Let's read this together. 7 marks. Interesting. But okay, guys, for what will happen is when I'm doing revisions, I know where to get my stoichiometry of electrolysis, but let's look at this one. It's looking interesting. Let's read together though. Consider the following standard equation, blah, 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 blah. What have they given us? Cell notation, right? Already from my cell notation, I see this as my what? Anode. And see this as my what? Cathode. Each half cell contains 200 cm cube, guys, 0,2. The cell is connected to a circuit and allowed to produce current until the concentration of the electrolyte in the cathode half cell is reduced to 0,5. Okay, wait, why reduced? What was the standard? 1. So our initial was 1. Now it's reduced to what? The cell is now disconnected. Write down a balanced equation for the net ionic equation. I think that one is quite straightforward, but let's get those 3 marks. It's copper and what? Silver. What are you going to have for copper? Do you notice that at the anode, what would you have? Cu to give us what? Cu2 plus what? 2E. And here we have what? Ag plus, what do? Do you remember, Shamin? What do you do here to balance? Huh? Multiply Ag by 2 and multiply this by 1. Write what on the left to the left hand side. So what are we going to have? Cu, because it's times 1. Let's come down. Plus 2Ag plus, we have multiplied that by 2 on the left. We go to the right, what do we have? Cu2 plus 2Ag. I have my 3 marks. 1 on the right, 1 on the left, 1 because it is balanced. Okay, let's hit that 7 marks and let's see what the examiner is all about. Calculate the concentration of the electrolyte in the half cell when the cell is disconnected. Where do we start from? Calculate what? Concentration in the what? Anode half cell. So we are looking for the copper half cell, right? Let's think together. The copper half cell. We do know the one in there. Okay. Let's try something. Let's try something. Yeah, we're going to use kind of the molar ratio. Okay, wait. We have the cathode and the anode, right? Which one is the anode again? This one is the anode, and this is the cathode. Since we're looking at the thinking, what are you thinking? Copper 2 plus?
The values using the H.
Okay, hold on. Let me see something here quickly. What's the ratio? Copper 2 plus is 1, right? And Ag2 plus is what? 2. I'm trying to use the table. What is the initial concentration? They are both 1 mole per dm cube, 1 mole per dm cube. They told us that one, the cathode one reduced to what? 0,5. Okay, so change. I'm trying to use the right table. Okay, and what do we have at the equilibrium, right? Okay, equilibrium. The copper one reduced to what? 0,5, reduced to 0,5.
The Ag reduced to 0.
No, nope. the cathode half, the cathode half cell reduced to 0.5, which is my Ag. Do you see why it's important to know the cathode and anode? Thank you, guys. Minus. So this will be what? 0.5. Now, according to our stoichiometry, what should we have? So this is going to be a plus. 0, what? 25. Add that together. What's our answer? 1.25. So the concentration of the what? Is it we're looking for the what? Cathode. The anode half cell will be what? 1.25 moles per cubic what? 7 marks. I don't know if it makes sense. No, yeah, I just used the table, and when I was doing grade 11 also, I used the table to do some stoichiometry. When I'm revising acid and base, I'm going to use the table to do some stoichiometry for you. Did it make sense? Yes, sir. I used the KC table. Okay, the KC table can be used for stoichiometry, and I'll be using that for acid and base. You'll see. Please don't. I'm going to do acid and base with the grade 11s from next week. Huh? No, when I did with you, I didn't use the table, but I want to introduce you to the table. They give us, but the volume remains constant. We don't need it though. If I was using the normal stoichiometry, I would have converted it to number. You see, I would have said initial number of moles. Yes, by using the 0. Can we try it? Too quickly as we close. Let's try it. If I wanted to use the volume, let's see quickly. What will it be? So I will have said ratio. Now, initial what? Number of moles. Change in number of moles. Then what? Equilibrium what? Number of moles, and equilibrium concentration. We have Cu2 plus and what? Ag plus. 1:2. Now, I cannot write number of moles as 1 here, although the concentration was 1. So number of moles or concentration is number of moles over what? Volume. What is my initial concentration? 1. I don't know the number of moles. What's my volume? So my number of moles will be what? So I am starting both of them as 0.2 moles. Then they told us which one became 0.5. Ag plus. Okay. Now remember, it is the concentration that becomes 0.5 of Ag. Convert that into number of moles. Or okay, no, not really. Check here. I can bring it here. What is the concentration of Ag? 0.5. This is number of moles, which is concentration multiplied by volume. What is my concentration? 0.5. And what's my volume? 0.2. What would that give us? 0.1. Yeah, 0.1. Now, that 0.1 comes here, right? Do you notice it's a decrease? This one will become what? An increase. Using your mole ratio, it's half of it. 0.05. Now, add downwards. 0.25. How do I get concentration? Number of moles divided by volume. 0.25. What's my volume? Give me an answer. Let's try. It's 1.25 because it's 2.5 divided by 2. 1.25 moles per. Here you're just going round around the village, round around the village, round around the village. I could have simply just stuck with my initial concentration, change in concentration. And I don't remember which province this question is. I'd love to see what they did. But anyway, makes sense. Makes sense. Which I don't remember the year. I have a feeling. No. How thing? I have a feeling. We're closing now, but I have a feeling. How thing? This is 2025, right? It's either 2024 or 2023. I just want to check quickly. I want to check something, then I'll release you. Past papers, 2024. Oof, it's not how 10. I want to see something quickly. Oh, this is the membrane cell that I told you they asked, and they had to cancel. It's the sodium chloride stuff. Okay. I want to see what they did. Official memo. Yeah, this is how thing. Come. Are you opening? This was question what? Do you remember? Huh? It's going to be almost the last one. Anyway, we'll see it. We'll see it. My heart is beating fast. We'll see it. They did a long way. What's the final answer? So long. 1,25 moles per. Is that the only option? That's the only option. Shame. Why didn't they ask me to do this memo for them? I should have done this memo.
So, if we had to do it during the concentration, we lose marks?
No, you lose no mark. Complete. So you'll see they converted back to number of moles, which we didn't need to, because the volume did not change.
And
So
then if your final answer is wrong, we don't get part marks.
no, you should get part marks. You should get. Oh, look at the 0,25. Look at the 0,25 divided by 0,2 that they did. Okay, but I think this one just makes sense to me. That table makes sense. Let me try to see if Elena were to do this. 7 marks. I want to mark definitely there. 1, 2, 3, 4. Because you recognize the initial concentration. So 1, 2, 3, 4. I just mark everything. Yeah. 5, 6. They just put mark anywhere. Because and it makes sense. So yeah, good. Good night, everybody. Ekes bayamuk. Good night, everybody. Good night.